In the first class, I have discussed the definition of Laplace transform and Laplace transform of standard functions called like constant function, exponential function, cos AT, sin AT, cos HAT, sin HAT, t power n. So you should be thorough with the definition of Laplace transform and the transform of all standard functions. You should be thorough with the definition of Laplace transform. So if f of t is a real valued function, if the function is multiplied with the kernel e power minus st, and if the product is integrated with respect to t from 0 to infinity, if the definite integral exists, then it is called as a Laplace transform of f of t. So only if the definite integral exists, we can have the Laplace transform. So it doesn't exist for all functions. That is why we have the condition it exists. So it is denoted by L of f of t or f of s or f cap of s. Then I discuss linearity property, and you should remember the proof of all the standard functions, and you should by heart the Laplace of standard functions you will be using in problems. Now today's class I will discuss the properties of Laplace transforms, and I will discuss a few problems in finding the Laplace transform using the properties. So the first one is shifting property. See, what is Laplace transform? It is how do you define Laplace transform? You define it as L of f of t integral 0 to infinity e power minus st f of t dt. So what is the meaning? The time domain is transformed to the frequency domain. You have the function in time domain. When you integrate, you get it as a function of s. So the time domain is transformed to frequency domain. So in shifting property, we see what happens when the time is shifted to the left, when there is a change in time. What happens when there is a decrease in time, and what happens when there is an increase in time, or when there in other words, what happens when there is a decrease in frequency or an increase in frequency. That's what we have in shifting property. So if L of f of t equals f of s, so it means that if the Laplace transform of the real valued function exists, then the Laplace of the product e power at f of t is f of s minus a. So if the Laplace transform of f of t exists, if the Laplace transform of real valued function exists, then Laplace transform of the product e power at f of t is f of s minus a. In place of a, if you have minus a, then we have f of s plus a. So, what do you mean by this property? So this gives you the Laplace when the a is replaced by, when f of t is replaced by e power at f of t, and when f of t is replaced by e power minus at f of t. Or in other words, what happens when the frequency s is decreased by s minus a, and what happens when the frequency s is increased to s plus a. So these two are called as the shifting properties of Laplace transform. We have learned the shifting property in Fourier transform also. Now the property 2, the derivative of the transform. So the statement is if L of f of t equals f of s. What do you mean by that? If the Laplace transform of f of t exists, if the Laplace transform of the real valued function exists, then the Laplace of the product t power n f of t is same as minus 1 whole power n fn of s, where n is a positive integer. If Laplace transform of the real valued function exists, then the Laplace of the product t power n f of t is same as minus 1 whole power n fn of s. Fn of s means nth derivative of f of s, where n is a positive integer. So we have from the first integer, when n is 1, positive integer means n starts with 1, f dash of s, f double dash of s, f triple dash of s, and so on. The third one, if Laplace of f of t equals f of s, then the Laplace of the f of t by t is integral s to infinity f of s ds. So, if the Laplace transform of real valued function exists, then Laplace of f of t by t is an integral s to infinity f of s ds. Now, you don't have to learn the proof for any of these properties. It's enough if you remember the statements. We'll be using in problems. Now, we'll discuss problems in using all the three properties. So, I have shared the properties in the table. So the first two are shifting properties. So whenever you have the product e power at f of t or e power minus at f of t, it means shifting property. When you have the product t power n f of t, it means transform of derivative. Or if you have f of t by t form, you have the Laplace as integral s to infinity f of s ds. Now we will see problems using all the three properties. So easily you can identify the type. So the first one, e power minus t cos square 3t. So you have the product. Whenever you have the product, it means you have to use the properties. So if you have an exponential term, it is very clear that it is shifting property. Whenever you have the product, whenever you have to find the transform of the product, you have to use the properties. So if you have an exponential term, you have to use the shifting property. So let f of t be e power minus t cos square 3t. So what is cos square theta? 1 plus cos 2 theta by 2. So 1 plus cos 6t by 2. So e power minus t into 1 plus cos 6t by 2. So split into 2. So take half out. You can write it as Laplace of e power minus t plus Laplace of e power minus t cos 6t. So half of Laplace of e power minus t plus Laplace of e power minus t cos 6t. So what is Laplace of e power minus t? It is a standard function. So it is 1 by s plus 1. A is 1, so it is 1 by s plus 1. And here you have Laplace of e power minus t cos 6t. So shifting property. What is Laplace of e power minus a t f of t? F of s plus a. So what is a here? 1. What is a here? The coefficient of t is 1. You see the exponential term. What is the coefficient of t? It is 1. So it is f of s plus 1. I repeat, you have Laplace of the product e power minus t cos 6t. So whenever you have Laplace of the product where one of the terms is an exponential term, it means shifting property. So what is Laplace of e power minus at f of t? F of s plus a. So you compare this with this. A is 1, so f of s plus 1. So take it as 1. So we only have to find f of s plus 1. So what is, so I have written the property here. So Laplace of e power minus at f of t is f of s plus a. So this implies Laplace of e power minus t cos 6t is f of s plus 1. So we have to find only f of s plus 1. We have to find f of s plus 1 through f of s. What is f of s? L of f of t. What is f of t here? Cos 6t. What is f of t here? Cos 6t. So f of s equals Laplace of cos 6t. S by, what is Laplace of cos 80? S by s square plus a square. So s by s square plus 6 square. So f of s is s by s square plus 6 square. It means f of s plus 1, you just have to replace s by s plus 1. See, whenever you have f of s plus a or f of s minus a, you have to get through f of s. So what is f of s? L of f of t. What is f of t? Cos 6t. So f of s is L of cos 6t. So what is L of cos 6t? S by s square plus 6 square. So f of s is s by s square plus 6 square. So it means f of s plus 1, just replace s by s plus 1. So s plus 1 by s plus 1 whole square plus 6 square. That is, that's what you have here. So replace f of s plus 1 by this expression. S plus 1 by s plus 1 whole square plus 6 square. So what is the answer? Half of 1 by s plus 1 plus f of s plus 1, that is s plus 1 by s plus 1 whole square plus 6 square. That's what you have here. Now the second one, cos h 2t sin 2t. Again you have the product. So what is cos h theta? Whenever you have cos h theta, write it in terms of exponentials. Whenever you have the product, it means you have to use properties. So first thing, how do you have the properties? You have the properties in terms of exponential, t power n or f of t by t. So here cos h theta you have to express in exponential form. So what is cos h 2t? So half of e power 2t plus e power minus 2t into sin 2t. So split into two terms. So half of e power 2t sin 2t plus e power minus 2t sin 2t. So take Laplace on both sides. So Laplace of f of t. So half of split into two Laplace transforms. So Laplace of e power 2t sin 2t plus Laplace of e power minus 2t sin 2t. Here, so whenever you have the product where one of the terms is exponential, it means shifting property. So this is of the form e power at f of t, and this is of the form e power minus at f of t. So what is Laplace of e power at f of t? F of s minus a. What is Laplace of e power minus at f of t? F of s plus a. So f of s minus 2 here, and here f of s plus 2. So half of f of s minus 2 plus f of s plus 2. So take it as 1. Now this is the answer. You have to get f of s minus 2 and f of s plus 2 through f of s. What is f of s? L of f of t. And what is f of t here? Sin 2t. What is Laplace of sin 2t? 2 by s square plus 2 square. So f of s is 2 by s square plus 2 square. So what is f of s minus 2? 2 by s minus 2 whole square plus 2 square. And what is f of s plus 2? 2 by s plus 2 whole square plus 2 square. So this completes the solution. So I will discuss the other problems in the next video.